move on.
Moving along, ladies and gentlemen, our next speaker, a little bit of a change in the program. Glad to say that Professor Yang has joined us. But I think in the interest of time, what we're going to do is we're going to invite Dr. Noah Silverman to come and present his thoughts. Noah has a PhD from UCLA in statistics. He has been very focused on AI for many years, even when it wasn't fashionable like it is today. The title of his presentation is AI Under the Hood, because he's American. So it's not under the bonnet, it's under the hood. So he's going to be taking a bit of a deeper dive. As I said, he's American, but I have to say he's actually a really nice guy. A little joke there to all my American friends. Don't take it personally. Ladies and gentlemen, please welcome Dr. Noah Silverman.
Thank you, sir. Appreciate it. Great intro. Thank you. All right, good afternoon. Thank you for coming out. Anson has given me 15 minutes to make all of you experts in machine learning and artificial intelligence.
Actually, you've got 10.
10 minutes. So if everybody would please grab a calculator and pencil, we'll get started in some of the calculus. I can wait. All right, that was a joke. But what's coming in the future of AI is not a joke. And it's something you all need to be aware of. We've seen a progression. AI is slowly replacing jobs and professions, as Ed was just talking about. The factory worker is going to go away. As we all know, Foxconn just replaced 60,000 workers with robots. There's a new project where someone has created a chef that's running off some robotics and AI that has this huge repertoire of recipes and is growing and growing. A lot of the fast food chains have also they're starting to build machines that not only can take the order and payment, but can actually cook the hamburger to order, grind the meat to order, slice the tomato to order. So fast food workers will probably be going away. Driving. I'm sure you've all seen the self-driving cars, but you know, Mercedes has a project with self-driving trucks, and they follow each other in a caravan. It's been tested very successfully in Europe, and they're now testing that in Nevada in the US. So at some point, truck drivers are going away. Finance, of course, we all know algorithmic trading and HFT, which is now accounting for a majority of the trades in the market. At what point will it replace human traders completely? And one of the more interesting projects, there are two now replacing lawyers. There's one called Ross and one called Peter. Ross actually is aware of, in the US, every law in the books and monitors in real time every court decision coming down. And you can ask it questions in plain English. If a company files bankruptcy under this certain law, can it still operate for business? And it will cite all the relevant case law and let you know exactly what the position is. So at what point do the junior lawyers, and possibly even the senior lawyers, go away? Peter, the other one, is a more consumer-friendly app where you can CC it in an email and say, hey, I'm talking to Edge, I need a quick NDA covering these things, sort it out. And the AI bot will draft an NDA, send it to both of us, ensure that everyone signs it, and have a executed, legally binding copy ready to download. There goes the attorney. It's going to do wills, it will do marriage contracts, it will do more and more. Now, why now? What's happened that there's this big growth of AI all of a sudden? And I think it's really three things. One, CPUs have gotten faster, as they always do, and they've gotten cheaper, as they always do. The other one is data. Storage is so cheap right now. That's a 10 terabyte Seagate drive that you can buy now in the Wanchai Computer Center for, I think, 800 USD. I don't know what the equivalent is in Hong Kong, which is super cheap. And storage like that years ago, I can't even imagine what that would have cost. The other interesting innovation is the GPU. Is anyone familiar with what those are? Okay, in the nerdy world of video games, the better the graphics, the more intense and high-def the graphics and faster they are, the better the game. So that's driven this massive innovation of these graphics cards. And this thing just plugs into your desktop PC. It's nothing special. This is the latest state-of-the-art from NVIDIA. It costs around, I think, 1,000 USD, maybe 900 with a discount. It has Your desktop computer has probably 4 cores in your CPU, if you know what that is. It means it can do 4 operations at once. This thing has 2,560 cores. That means it can do 2,560 math operations in parallel at the same time. To give you some perspective, it can process what's called 9 teraflops of computing speed, which I know that's a weird expression, but to give you perspective, IBM's hottest supercomputer in the year 2000 only did 7.8 teraflops. Now, the supercomputers that are Alibaba and Google are building are more than this, but I can buy this for under 1,000 USD and stick it in my home PC. So again, AI is getting very accessible. There's tons of data. The computing tools are very inexpensive. The other interesting innovation is software. There are now turnkey software packages that you can download anytime you want, install on your laptop. In 20 minutes, you can be doing AI and machine learning. Easy as can be. You can buy a big hard drive, you can buy a graphics card, download some open source software, and you're now an AI engineer. So that's made it very, very easy and accessible for people to develop these types of things. This has also given rise to a problem. It's what I like to call the microwave cooking of AI. Or to put it in KPMG terms, if I got really good at QuickBooks, I could say I'm an accountant or an auditor, but I'm nowhere near in the league of KPMG. So what's happening is there's this whole rise of people that have taken an online course for 3 weeks, downloaded some open source software, maybe they did a little IT work somewhere in a company, and they're now machine learning experts or data science experts. But they're not. And for turnkey, simple toy problems, it's great. What's missing is domain expertise, understanding the problem you're actually trying to model, understanding the hard and difficult and challenging parts of the mathematics and the interesting edge cases where AI is really going to make a difference, understanding the business relationship, how do you actually apply this to business and integrate it into an existing operation. So while all this easy accessibility is fantastic, you also need to be aware that it's a real area where there's a small handful of people in the world who are experts on this. Now, briefly, we're going to look under the hood, or under the, I believe it was bonnet, Hanson called it. From my perspective, and I work as a consultant, so I help companies solve AI problems. You can solve any problem in 4 steps. First, what's your objective? What is the question? What are you trying to answer? And a lot of companies will jump in and say, we need AI, we need big data, and they don't know what they're trying to do. Define a question. What's the goal, right? What data do we have that can help us with this goal? Do we have it already, or do we need to go collect it, and how can we get it? Okay, let's come up with some statistical models that can help answer the question given the data. And none of this is new. People have been doing this since the 1940s or 50s. And then once you have this information, you have some model, what kind of decision process? What do you do with this? Do you execute a trade? Do you hire an employee? Do you make a real estate transaction? Do you issue a report to a client? What do you do with the data? And that's where the seasoned experience of a non-tech person is so important. Very briefly, as Anson only gave me 10 minutes, we're going to look at 3 types of machine learning. Because in my perspective, AI is just machine learning under the hood. There's regression, there's classification, and there's missing data. Regression is trying to predict a number. What will the price of a 600 square foot flat in Kowloon be 2 years from now on the 30th floor? How tall will the next person who walks in the room be? What will the blood pressure of the patient be after this medicine? It's a number. Classification, and this is where a lot of the interesting, trendy news is coming out, is you're just making a yes-no decision. Will the patient live or die? Is this a picture of a cat, yes or no? Should the self-driving car step on the brakes, yes or no? So that's a yes or no decision. And missing data is used a lot for recommendation engines. If you have a list of things I've bought that I like and a list of other people similar to me, things they've bought and they like, well, for a product, I don't know, for this clicker, I haven't bought it yet, so you don't know what I'll think of it. That's a missing data problem, and you can solve that using something called matrix factorization, which we're not going to get into the math. So there are more areas of machine learning and AI, but these are the 3 big sections. Now, in machine learning and AI, it becomes a game, and the game is, can I be less wrong? There's a famous quote, all models are wrong, but many are useful, and that's true. And these 2 photos are examples of being wrong. If you look at the one on the left, that's regression. That's the best line to fit that data. Doesn't matter what the data is. If you ran a big sophisticated computer algorithm or even a simple one in Excel, you'd get this line. And if you'll notice, most of those points don't touch the line. So it's actually wrong on most of those points. But you've learned something, and you can study how wrong is it. On the right, we have a classification problem. And again, between the red and the blue, we've circled where the algorithm was wrong, because it's all about being less wrong. And that's where the art meets the science. I'll give you 2 examples. For one client, we were modeling price of electricity in the US, and we came across a problem. We were getting these weird errors a handful of times a year, and we couldn't figure it out until we studied the calendar and went, oh, those are holidays. People are home on the holidays. The factories are closed. The demand changes. So we added another layer to the model. Another thing you can get is sort of some free data or free insights. We're modeling a chain of training schools and students dropping out. And we found that the students who were leaving, when we interviewed them, they were from lower income families, and they often left because they had to go work to make money for the family. So the school was able to do some things to help with that. But the other thing we learned is that, hey, some teachers, even when you account for that, the students are still leaving. Well, shoot, they're just bad teachers. So that wasn't the goal of the project, but using the machine learning, we were able to get some extra benefit out and help the school identify the teachers who were scaring off the kids. Now, it's a little hard to see on this slide, so I'll summarize. There's a general process here where you look at some phenomena in the world, you propose a model, you collect the data, you see where you're wrong, add some more data, adjust the model, and it becomes this loop, or this loop of a process trying to be as less wrong as you can. And this can apply to lots of any of these machine learning techniques we've covered. A brief tangent, deep learning, which is getting all the sexy news right now, and how Google won AlphaGo and all that stuff, has no structure to it. It's designed for processing images and processing sound, and it's a neural network which was developed in the 1950s that's been added many more layers and new technology and new math, and it lets you do this without being an expert in your domain. The problem is it only works for certain areas because you don't have all the expert knowledge. But it's neat, and you can download all these toolkits at home, and you can identify a picture of a cat, so it gets a lot of trendy news, although it's not the answer for everything people would like it to be. What I see, on the bottom, we're looking at the size of data, and across the side, we're looking at complex models. And a lot of the work right now is making very complex models with some small data. The areas that deep learning addresses is in the upper right, big data and complicated models. And an area I work on that's not in this talk called hierarchical Bayesian modeling also addresses that. But if you're looking at investing or developing or innovating, that's the interesting area, big data and highly complex models, and that's where it starts to get hard. And that's where we need new things developed. Quick example, self-driving car. It takes a camera, first thing it does is some image processing, recognizes a stop sign, then there's some decision tree. Well, what do I do when there's a stop sign? Obviously, step on the brakes. How fast do you brake? Well, that's a function of your risk and your objective. You don't want to scare the passengers. How long do I stay at the stop sign? Well, that's a function of traffic law and minimizing risk. So self-driving car, your objective is let's minimize the drive time, but you have some rules. Let's not break laws and let's minimize injury risk. You can't say zero risk because then you never leave the garage. But it's an example of how a complicated, what seems like a magical system, are really some fundamental steps of machine learning under the hood. Quickly, I looked at the pricing right now. I can build a PC at the Wanchai Computer Center with 20 terabytes of data, 2 of those Massix graphics cards, tons of RAM. In other words, what would have been a supercomputer 15 years ago, it's now about $4,500 USD, and I can have it delivered tomorrow. So this stuff is really accessible to anybody. It's not hard to get started. How you apply it and what you do with it is much more complicated, but it's easy to start. And let's finish up with a few examples of some interesting applications of AI. There's one group called Predicat I did some work with out of the US, and they provide a service to insurance underwriters, and they scan all the published medical research that comes out every morning looking for chemicals identified that might cause health risks or cause cancer in the future or make people sick. So then they can advise insurance companies, hey, you may not want to underwrite that factory anymore because there's new research on the chemicals that they're starting to use. Product recommendation is a big area. Financial services, what products do we recommend to our clients? When our salesman picks up the phone, we want a screen that tells us this client likes these kinds of things, this is their risk profile, this is the return they've made so far this year. Based on machine learning, this is the product you should talk to them about. Self-driving cars, of course. There are a few hedge funds now that just take Twitter feeds and actually make investment decisions based on sentiment from Twitter feeds. Chicago's working on predictive policing, where they've actually identified people, given the relationships, gang affiliation, arrest records of known associates, and they'll go up to somebody and say, hey, Anson, we think there's a good chance you're going to attack somebody next week. And they're actually paying people to stay home. They're saying it's cheaper to actually give them the money to stay home and not commit the crime than it is to police it. So they're doing predictive policing. And it looks like we're out of time, so thank you. And again, my name's Noah Silverman, and I'm available if anybody has questions.
Thank you. Thanks, Noah.